video is on finding the difference between 2 points. So this would be a question if you're looking at a coordinate plane and this is a point and this is a point and it says find the difference. Well, you can't exactly count. You can estimate, but you can't exactly count to find the distance or to find the distance between here and here. So think about what we learned yesterday and the day before and how you might find the distance if you know 2 points. So if you thought about the Pythagorean theorem, then that would be correct. You can find the distance between here and here and find the distance between here and here and use the Pythagorean theorem to find the distance across, to find the hypotenuse. And the same here, you can find the distance and the distance, square this, and that you add those together and that would give you the square of the hypotenuse. Now, there's a little bit faster way to do this. It can be used to find the distance between any 2 points, x1 and y1 and x2 and y2, the Pythagorean theorem can, in the coordinate plane. The resulting expression is called the distance formula. So I actually put it into a formula so you don't have to be worried about what am I using. So with this, it says in a coordinate plane, the distance between D, between 2 points, x1, y1, and x2, y2 is distance equals the square root of the square of x and the square of the y. And that's what you would think it would be, right? It would be the x squared plus the y squared would be c squared and take the square root of it. So it just puts it in a nice formula for you to be able to use. So if we have points 1, 6, and 5, -4, and we want to find this distance, okay? So, and we've got 5, -4. So I have x2, 5, minus x1, 1, and that would be squared, and this would all be the square root, plus y2 minus y1 squared. So this is 5 minus 1, which is 4 squared, and this is all the square root, plus -4 minus 6 would be -10 squared, would be 10 squared, and so this would be 16 plus 100, and it would be the square root of that, and I would need a calculator. So the square root of 116 would equal 10.77. And so that is the distance. This distance would be equal to 10.77. So it's real nice to have this formula, but again, it is these squared and the square root. So you're going to be given some word problems with this, and the numbers could get kind of crazy, but it's still very manageable if you have your distance formula. So this says Emily wants to find the distance between her house on one side of the park and the beach on the other side. So here's her house, and here's the beach. And we've got this distance and this distance. And we want to use the Pythagorean theorem to find out how far the beach is if she cuts through the park. So if she's going diagonally through the park, how far is the distance? It's going to be less than walking this length, and that's why she wants to cut through. But we want to find the distance. So we have our points are 5, 10, and 25, 36. So we want the square root of x plus, so this is x2 minus x1 squared, and then y2 minus y1 squared. Y2 minus y1 squared. So the square root of 20 squared plus 26 squared. Now 25 minus 5 is 20 squared, and then 36 minus 10 is 26 squared. So I'm going to use my calculator, and I think I know 20 squared, and of course that is 400. Now I do not know 26 squared. So I'm going to do it on the calculator, 676, and I'm going to add these together. 400 plus 676 is the square root of 1076, and I'm going to use my calculator to do square root of 1076 equals 32.8. And so the distance across here is 32.8 yards. And it'll usually tell you what to round to. This is round to the 10th. If I rounded it to the whole number, it'd be 33 yards. And 33 yards would be, what you would think of. You wouldn't say 32.8 yards. You'd say it's 33 yards away. But that gives you an idea of how to use the distance formula to find the distance between 2 points on a coordinate plane, or given 2 points in a picture like this. And you just follow through the formula and you'll get your answer. Now it's time to practice your workbook problems.